Hello, friends. Welcome to the Georgia Tech AI podcast. My guest today is Christopher MacLellan, an assistant professor in the School of Interactive Computing at Georgia Tech, where he runs the Teachable AI Lab. Chris is asking one of the fundamental questions in artificial intelligence. How can we build AI systems that learn and teach like humans do? While much of the AI world is rushing towards large language models, Chris is asking different questions. What if AI could learn from just one example, much like humans do? What if we could teach AI systems, much like we teach one another? Chris is not building technology in isolation. He's deeply concerned about the societal implications of AI, particularly in the education space. And now, dear friends, please welcome Christopher MacLellan. So Chris, to start off, I wanted to read you this excerpt from Models of My Life by Herbert Simon. For most of us who have not won $1 million lotteries or suffered crippling accidents, life is much like a chess game. We make hundreds of choices among the alternative paths that lie before us, and as a result of those choices, find ourselves pursuing particular, perhaps highly specialized careers, married to particular spouses, and living in particular towns. This kind of biased random walk describes very well my own choice of occupation. The bias, though perhaps slight, gave it direction. How would you say that this semi-informed random walk has emulated your own career trajectory into human-computer interaction?
Yeah, so I love that you started with a quote from Herbert Simon, who I joke is like my spirit animal. He's a real role model. But to answer your question, you know, my path was not linear. So I started off doing work in math, actually, and discovered AI in my undergraduate, and I'm really interested in trying to understand how the mind works. Sort of the original goals of AI was to build minds and to understand how minds work through the construction of minds. And I went to graduate school. I actually started at a different PhD program than the one that I ultimately ended up at. My area of study was AI. And what I found was that I ended up spending the vast majority of my time trying to make AI algorithms that were slightly faster, slightly more accurate, slightly more data efficient, and it wasn't really what I wanted in terms of trying to understand how the mind works. And I decided that I needed to make a change. I ended up switching advisors and working with somebody named Pat Langley, who actually is one of Herbert Simon's students. Yeah, that really sort of got me moving in the direction of what a field of study called cognitive systems, which is, how do we build computational artifacts that can do the things that human minds can do? And unfortunately, when I moved to work with Pat, he actually had just accepted a position in New Zealand. And so and this is like to your quote from Herbert Simon, like all the random variables and the things that are happening, and you're making strategic choices and moving. I ultimately ended up reapplying to graduate schools again to try to continue this kind of area of work, and I found my way to Carnegie Mellon and working with Ken Kadinger, who at the time was looking for a student who would help him build what he called simulated students, computer models that could simulate how people were learning within tutoring systems and through practice, which is like exactly what I wanted. I mean, I couldn't have come up with a better thing for myself if I had chosen. So it was a really good match. And then what was interesting about that was that when I was a PhD student at Arizona State in AI, I had taken all those like sort of core AI classes, but they actually had a thing where they wouldn't let you get a master's and leave. So I had to sort of like jettison a lot of that credit and the time I had spent. But what I did instead was I decided that I wouldn't try to take more AI classes. I would try to broaden my understanding. And at CMU, in the Human Computer Interaction Institute, it is the premier place to study human computer interaction. And so I studied human computer interaction, and there's actually a really, really strong cognitive science, cognitive psychology department at CMU, which is where Herb Simon was. And yeah, so I studied the science of learning, like how people learn and human computer interaction. And so in some sense, it gave me an opportunity to go broader than I think many people have the opportunity to go. And yeah, it just sort of made a unique combination of skills that, I bring to each problem that I look at from this sort of interdisciplinary perspective of basically three disciplines, AI, human computer interaction, and the learning sciences, or cognitive and learning sciences, I think even more broadly. And yeah, I mean, that's just flavored all of the work that I do.
It's fascinating to hear the interdisciplinary approach and how that's fueling your lab currently, the Teachable AI Lab. The key question, how do we build systems people can teach and interact with like they would another human, while still taking advantage of the key non-human features of AI ML systems? Could you unpack that for us?
Sure. So, I mean, maybe a very timely example would be large language models. I mean, everybody's, I think, got some experience with them now, or most people have, interacted with ChatGPT. They do have a lot of human capabilities. They're able to do a lot of tasks that people can do. You see the New York Times headlines of like they take the LSAT and they do better than most people do on the LSAT. But one thing that they do not do is learn as well as people. They require several orders of magnitude more training data than I will ever experience in my lifetime. So humans are incredibly efficient, and they're really good learners. And culturally, humans have evolved. I mean, one of the key things that distinguishes, if you look at research, there's a researcher named Tomasello, and he does these comparative studies between apes and humans, and he tries to understand what it is that makes humans unique from other primates, other species. And he would argue that one of the key things that sets us apart is culture, and the ability to. It's faster than evolution. Like you and I, we have this conversation, we exchange an idea. Like now you have that idea. It doesn't take multiple generations of evolution to transmit that idea. And so I would say that one of the things that humans do is cultural transmission of knowledge. And one of the things that systems like large language models do is they don't do that, right? They are synthesizing it from all of our data. But you can't teach. I mean, there are workarounds that people are doing with things like RAG, having a notepad that has facts about you. But really, you're not fundamentally changing a language model when you interact with it, and not in the way that people do. Like you are learning things, even from this short conversation, that changing the way that you think about things or do things. And I guess my interest in teachable systems is to try to capture how can we build AI capabilities that enable us to transmit knowledge culture, like socially, culturally, dyadically, so that we can build systems that exhibit this sort of key differentiator that humans have. Rapid learning, like socially mediated learning, and if we can build systems like that, I mean, I think there are many practical applications and implications of having technologies that can do that. And so that's the goal of my group, is to try to figure out from these different disciplinary lenses, learning science, where we study how people transmit knowledge, HCI, where we figure out how to design interfaces that are natural for people to use, and AI, like how do we actually build a system that can learn from one example, not 10 million examples. And so we need really all of these different disciplines together.
When you talk about making interactions natural, there's one work, The Apprentice Tutor Builder. And there's one quote that you came up with during one of the presentations of it that said, if you support teachers, you support learners. What's an ideal characteristic for a good tutor to have that LLMs are not able to replicate?
Well, there's many. The one that immediately comes to mind is factual correctness, in the sense that large language models are built on this idea of statistical next token generation, and there's always errors, and the errors will accumulate exponentially as the sequences become longer. And it's almost inevitable that in longer sequences of problem solving, there will be high probability of errors appearing. In contrast, it's like you have a teacher who's taught this subject for 5 years, or an AI tutor, an intelligent tutor that we've designed to be 100% correct. And when you make mistakes in the instruction and those mistakes become misconceptions in students, misconceptions are incredibly difficult to repair in people. So I would say one immediate thing around LLMs, and one thing I'm concerned about with using language models in education, is their propensity to make mistakes, or what people would call hallucinate. I don't really like that term. They're just incorrect in my mind.
How can we ever reach a time where technology bonds with the student that it's teaching, that can be a lifelong companion, much like we saw in the Diamond Age, for example? Are we headed in that direction at all, or do we need to support our teachers currently more?
I'm trying to read between the lines a little bit on your question here. I think that AI should serve a role of supporting teachers in the missions that they're accomplishing. I think part of that is that I don't think that the technology is there to replace a teacher or a coach or a family member or a mentor as a learning companion. And in some sense, I'm not sure we would want to do that. Even in the science fiction books, it's great. There is, I think, a beautiful vision there of giving people access to these things, teachers, coaches, mentors, if they don't have access. And I think part of the sort of promise of AI is giving access to those things, where it would otherwise just not be possible. But at the same time, people that have access to those things, I don't think that those are an equal replacement for a human. And at the very least, like, your teacher or your mentor is also a human. Like, they understand socially, culturally, the experience of being human in a way that the language model does not. And I think it will be very difficult to translate that. Now, I could be wrong. Predicting the future is a fool's game, so I try not to. But I wouldn't bet on that. I think our better path would be to figure out how to support people in expanding their mentorship and coaching and teaching reach. Like, you want to retain the human component, the human element to... that's what, again, like I was saying, that's what makes humans special, is social, cultural transmission of knowledge. It's part of the human experience. And I would be cautious about trying to remove humans from that.
No, absolutely. And even in my learning, I feel the relationship I have with my teacher, that bond is inextricably tied to my own learning progress. Could you expand on how technology can be an enabler for teachers versus an impediment?
Sure. Yeah, I think there's been decades now research on intelligent tutoring systems. And intelligent tutors, I guess the goal of that research is to replicate human tutoring. A coach guiding a person in solving problems, giving them feedback, helping them to solve it. And there was some very early work on this idea of like 2 sigma improvement that you could see up to 2 standard deviations in learning improvements as a result of working with a one-on-one human tutor. And intelligent tutoring, the community was trying to replicate that, to say that maybe not everybody can afford a tutor or has access to a tutor. And maybe we can give them a computer tutor as a substitute to try to get some of the effects of one-on-one tutoring. And I think there's been several review papers that have sort of analyzed like meta-analyses of some of the tutoring results. And I think they argue that we have effectively achieved almost parity with having a one-on-one human tutor. Now, I do think that is quite impressive. Being able to get a letter grade or part of a letter grade improvement as a result of using AI. You asked about how that would fit into supporting a teacher. Well, what that means is that, a teacher who's already often very short on time. Usually they're incredibly overloaded with work. They can't provide that social, emotional bond. They can't provide the rich social support when they're spending all their time teaching every one of the little, focusing on the sort of low-level instruction. And I guess what I'm envisioning is that tutors, instead of doing your homework, you can work with AI tutors, or they can help you in a way that is based in science, like science of learning, and is going to be more pedagogically informed and helpful. And that can offload some of the work from a teacher so that they can spend more of their time providing that sort of more lifelong mentorship and coaching and support that the AI technologies probably cannot provide. And so I guess I view it as a symbiotic relationship between teachers and AI agents, that they're like on a team. It's like the AI agents are like the teacher's assistants that can help offload the really tedious, low-level, some might say things like drill and kill. It is important to learn those basic skills, and having AIs that can do that rather than having to have teachers do all that kind of stuff.
What makes an interaction natural between a teacher and an AI, and between an AI and a student?
Great question. I don't completely know the answer. I would say I can tell you what some people have suggested and what I think is wrong, and I can kind of give you a hint at what I think is right. So what some people might say, and what I've seen in many papers around the naturalness of interaction, is that they often attribute naturalness to the modality. So they will say, if the interaction with the system is in natural language, it will be natural. That is totally incorrect. Language has, there's work by like Don Norman, The Design of Everyday Things, and he mentions this concept that comes from Gibson on affordances. And the idea is like the form of a thing should communicate to you how you interact with it. So it's like the classic example that they give is like, doors at like a hotel. And when it has a handle, that has an affordance that you should grab it and maybe pull. When it has one of those plates, that's like a push, or, the bar, like that signals to you that has an affordance of being pushed. Language interfaces like your Amazon Echo or your Siri on your phone or your, voice chat GPT, even your language chat GPT, they lack affordances. So people don't know how to interact with it. Like it doesn't invite you to interact with it in certain ways. It's too unconstrained. I actually think that natural interactions, I believe that people develop social schemas for how they interact with things. You go to the coffee shop, you place your order, you pay probably before you get your coffee. There's sort of a script that we all follow, and that script is socially co-constructed through your experience going to coffee shops with your parents, and then maybe you going by yourself, and maybe going to other shops. And I guess in my mind, what's natural is not so much about the modality as it is about designing interfaces that understand the schemas that people bring, and designing interfaces that are compatible with those schemas so that you don't have to change the norms. The system is designed to fit within the ways that you would interact with another person. So often in my work, I use the metaphor of like, how would you interact with me? And I try to study that through our work with tutors, through our work in classrooms with human learning. Like, people have evolved over many generations, the ways that we transmit knowledge to each other. We have patterns. You give me examples. You question me. You correct my mistakes. These are different kinds of patterns that we use, and we try to design AI systems that are compatible with those patterns, that have been sort of evolved over, human culture. And my belief is that those consistency with the patterns that we all have in our mind that we use with each other will make these systems more natural for people to use without training. We're leveraging the knowledge that you already have of how to do it. But it's still challenging. I mean, people form new schemas around how they interact with their echo. And that changes. They would interact with an agent differently than they would interact with a human. And so, I mean, it isn't very straightforward, I don't think. But I think it's more about understanding the norms, the patterns, the schemas that we use to interact with each other, and designing systems that are compatible with those.
This ties in very well with the concept of mutual theory of mind. The reason that we are able to collaborate so well is because I have some model of what you think about me, and you have some model of what I think about you. And that helps us cooperate really well. With AI agents, that link might be missing. Could you talk me through the OpenAI 5 example and how human AI dynamics completely broke down?
Sure. So you're mentioning OpenAI 5. I guess for you and others, maybe to give a little bit of context, OpenAI organized this competition around the game Dota 2, Defense of the Ancients, and they organized the competition so that there was 5 professional Dota 2 players on the pro circuit, and 5 reinforcement learning agents that had learned to play Dota 2 through self-play, similar to the work on AlphaGo and these other systems. They played against themselves to explore the state space and learn a policy for how to play this game. And, in some sense, they are getting at aspects of teaming. It's team. I think OpenAI 5, the 5 refers to the fact that it's 5v5. So there's 5 AI agents and 5 human. And they competed against each other, and in the competition, under certain conditions, I think some people argue that maybe the AI had an unfair advantage because it can click faster than humans can. But under the constraints that they gave, the AI agents were able to beat the humans. So in some sense, they've acquired necessary skill to play the game. It's not about, they have the game knowledge. But they did this interesting follow-up match where they did mixed teams. So they had, 2 humans, 3 agents against 2 humans, 3 agents. And there was a lot of very clear breakdowns in the way that the humans and the AI agents team together. And one of the players, I think his name is Blitz, talks about how playing with the AI was like trying to solve a puzzle while he was playing Dota 2. It was like he didn't know what it would do. And there were many cases where he believed that when the AI agent didn't agree with him, it would just abandon him to be killed by the opposing team. It would just leave him high and dry. And this gets at what you're talking about around this theory of mind idea, is that the Blitz, this idea of it being a puzzle, is he does not have, it's like a black box. He doesn't know how this AI agent is working, what it's doing, why it's doing what it's doing. It's a little bit of a mystery to him. And that makes it very difficult to coordinate, with a a teammate that you don't understand how they're even or why they're doing what they're doing. In the case of humans, it's a little different in that, you and I are both human, and we both raised in human society, and we have a general sense of like how we would make decisions, and we can extrapolate from that to our teammates, even a teammate that we've never worked with before. Like we have the shared experience of being human, and existing within human culture. And that AI agent does not have that. Like we don't have that we can't project how we would do things onto that AI agent because it is alien, in how it thinks and makes decisions, right? So, yeah, I mean, I would say a fundamental challenge in these AI systems. If we want people to be able to team with them, like we have to figure out how to bridge that gap between, like, people need to be able to form theories of how their AI agents that they're working with work.
Yeah, absolutely. And there's a paper you came up with recently, Verbal Apprentice Learner, VAL. There are certain paragraphs that are just, it's truly a delight to read. So let me quote one of them. The models we used are not open source, and the centralization of foundational technology behind the veil of a corporate API offers almost no transparency, both into how the technology works and into how the data sent by users is being used or stored. Talk me more through this black box approach that everyone in research is just running towards and the need for greater transparency in AI research.
Sure. Wow. I don't remember writing that in the Val paper, but I believe it sounds like something I would say. Yeah. I mean, I think I have a lot to be concerned about. And in some sense, I think that right now language models are really dominating the conversation. And language models are interesting in that the amount of resources required to construct and operate language models is prohibitive for many things. Like corporations are particularly well suited to engage in that kind of work in a way that like an academic lab like my own isn't able to bring $1 billion to bear to train a model and suffer potential losses in a way that maybe OpenAI, for example, is. So in some sense, there's an asymmetry there around the technology. Now, once these corporations, Google, Meta, OpenAI, they create these models, and some of them are open source, right? I mean, I think Meta does release the Llama models, and, I think yesterday I actually just saw an announcement that OpenAI is releasing their it's ChatGPT OSS or whatever. I mean, I haven't read into the details, but there is an effort to make some of these models open. But even then, like they control how those models are built. They control the training data. We don't know how those systems are built or what information was used or what copyright violations were done in order to construct those models. And so in some sense, it takes a lot of control away from people that are using them. Now, the thing that really concerns me is that we're putting all our eggs in the LLM basket. I mean, everybody's it's like if you look at the major conferences in AI, triple AI, NeurIPS, like these kinds of things, it's dominated by a lot of these like transformer based, vision transformers, like data and scale is all you need. If you look at HCI, also dominated by like people using language models and figuring out new ways to interface with language models. And I worry that it's like in HCI, there's a distinction between technology-centered work and human-centered work. And I would say that right now, a lot of the work is being driven by technology. Like we have a hammer, and we're trying to figure out how many different kinds of nails we can hammer in with it. And the problem is that there are fundamental limitations of language models. They're very expensive to train. They're difficult to update. when you have new data, you interface with your ChatGPT system, and I think the new models come out like every 6 months, and you have to wait for updates. They own that model in most cases. I mean, I guess the open source ones are often released under some permissive license, but they have all the data and the resources to train those, and it makes it very difficult for like a nonprofit, a research lab to change and affect those technologies, to meet some human need. I'm really interested in if there's ways that we can come up with alternatives. Like Google and OpenAI, they are very focused on big data. All data and scale is all you need. They have a lot of the data. They have a lot of the scale. They are not going to go after technologies that are about small data, small compute, small, that's just all of their resources are aligned around this idea of big data, big compute. And so like part of the focus in my lab has been going after things that don't even make sense for corporations to go after, but do make sense for enabling new kinds of human computer interaction, where you can adjust a model to fit your needs. It makes a mistake, you can correct it. Like these are things that are sort of with the way that a lot of the large language models are trained and work. And so in some sense, I guess I'm proposing that we need like fundamentally different AI capabilities to address many of the human needs that come up in my work. That LLMs aren't the answer for all these.
Yeah, and a simple example, we don't require so much training and compute. We're pretty data efficient
and power efficient. Actually, I don't know, remember the exact miles per gallon. Like if people could consume gasoline and like how many joules like calories of energy, it's like thousands or something, hundreds or thousands of miles per gallon. Like we're very efficient compared to many machines.
So take me through what we need to build third wave AI capabilities. So this is a position paper that you had written on human machine teaming, and you clearly outlined the three waves of AI. The first wave, KB, knowledge-based AI. Second wave, what you just talked about, machine learning-based approaches. What is the third wave that we need in order to build human-like intelligence?
Sure. So I guess let me reframe slightly the three waves and I'll give you my take. So in the first wave is, as you were saying, it's engineered systems, knowledge-based systems where the knowledge is actually based on human knowledge and in some sense has an interpretability component, but there's a huge cost to building the systems. I mean, the limiter there was that all these systems had to be built. The second wave really is, you were saying machine learning, but I would argue is really primarily data-driven. It's this idea that data is how we produce these machines. They're not engineered, they're not built, they're derived from data. And many people, like if you look at, there's actually like a YouTube video from one of the DARPA directors on what he talks about these three waves. And there they talk about like neurosymbolic computing, like this idea of bringing the benefits of knowledge, the benefits of grounding in human terms and ideas, and the benefits of data, and like combining them to get the benefits of both. I like the idea, but I think it's actually missing some things. In my mind, third wave will have more of an element of being able to have, for people to affect the systems that they interact with, and so in some sense, second wave is like we're using the data of the internet. Like we've produced all this data over, since the invention of the internet, we've been producing data and it's using all of that. Third wave, I think, is more about being able to give new data and have the system adapt to that, and in ways that are human compatible, human relatable, like knowledge-based systems. I'm not necessarily saying that it has to be engineered, but it should still ground in human semantics and meanings, in a way that, LLMs kind of do. Their input and output is language. But internally, it's quite a black box. And I guess I'm thinking that, like, in a knowledge-based system, you put a rule in, and the rule expresses something that you know to be true. And when that rule fires, we know that's the rule that we know from math or medicine or finance or whatever it is that, that rule is expressing. And in a language model, we do not know. And that's part of the reason that they generate mistakes. They're incorrect, is that they don't have strict rules that are grounded in the knowledge that we have accumulated as humans. And I guess I'm thinking that more of like human engaging directly with these systems, like maybe when I talk about teachable systems, I actually think in my mind that's more of like a third wave where maybe there is elements of the neurosymbolic happening, but I guess the primary differentiator would be that similar to like where does the knowledge come from in each of these three waves? And in the first wave, it's like the engineers build it in. In the second wave, it's from all the data, but it's like found data. It's like it's existing data. And I guess in my mind, the third wave is like interactively, you are putting the knowledge that you need into the system, and it's coming directly from the users. And maybe that's more of like where does the knowledge come from? Like a human focus than a technology focus to the three waves. And maybe technology-wise, maybe it is something like neurosymbolic. But that's my take.
With regards to your transparency comment, I will say humans aren't always very transparent either, and we also have bounded rationality.
Sure.
How do you wrestle with that tension?
Well, so if you remember at the beginning of this call, you were talking about like these teachable systems that, are able to do the kinds of things that humans can do, but are not limited to the constraints of humans. I think one of the areas where we should be superhuman with technologies is transparency and explainability. We can be better than a human. And we should be. I mean, there's no reason. It's a machine. We built it. Like, we should be able to say why it did what it did, or to produce justifications in a way that's better than a human. That's one of the few areas where I think we can easily. I don't think it's easy because it would have been done probably. But I think it's possible to exceed humans.
It's also fascinating because with the Apprentice Tutor Builder, you did all of these qualitative studies and people explicitly told you that what would be characteristic of an ideal tutor? Something that's going to have a conversation with you rather than feeling like I'm plugging something into a calculator. So people clearly feel that way. What do we need to do in order to build such ideal tutors that are able to learn from experience and coexist with us?
So I'm just going to say there's a lot of challenges in the thing that you're saying. One thing I will highlight that has come up multiple times in my work is that people often have a sense of what the ideal tutor would be. And most of the time, the intuition for that is wrong. There's a lot of work on, like, people talk about there's a classic study on whether it's better to watch videos, like lecture videos, or to do tutors where you are like basically solving homework problems with feedback. And people say that they enjoy the videos more, they learn more from the videos, but if you measure it, like with a pre-test and a post-test, they actually learn more from doing the homework. So one of the real challenges in the education space is that everybody feels like they're an expert in their own education, and they have an intuition for their own self-assessment of their learning and their competencies and their capabilities. And I would say that often, very often, those intuitions are wrong. So there's a real challenge here. And I don't have a good study I can point to. There is one study I've come across where they assign people in physics to using language models as tutors versus not having any support, and the language model people actually did worse. Where there's a feeling that it's easier to have this kind of conversational interaction. And, well, in their case, it's offloading the thinking into the LLM. And because letting the LLM do the thinking, they're not doing it, they're actually not learning. But they feel like they're learning because they're able to do more things with the assistance of the LLM than they could otherwise. So there's this perception that they're learning more, but they're not. So I say that, now coming back to your point about the comment from this apprentice tutor builder work, I think what I'm really interested in is grounding these teachable systems in the science of learning. So how do we design the interactions to not just be perceived to be better, but actually be better? Like, what is the efficient way to teach an agent? And it may not be natural language. Maybe it's like, one of the jokes with around natural language is that like a natural language interface, some of the early work on natural interfaces, like a keyboard and mouse is actually one of the most efficient interfaces that has been engineered. Like in some sense, people are more efficient at using that than they are at using like natural ways. Even touch and other things may not be as efficient as a mouse. Like there's a reason, you play, Fortnite or whatever. Like people are using keyboards and mouses and game pads, like, because those have been engineered for usability. But I guess what I'm saying is that it's a challenge. The whole point, the reason we need science is to pick apart what actually makes the learning experiences and the transfer of knowledge more efficient. Like if you want to transfer your knowledge into an agent, the agent wants to teach you, transfer knowledge back into you. I think we really need to use science to understand what is the right way to do that. It can't be based on subjective perception because, almost every study that we do, people say things that don't agree with the science. So, I don't know. And it makes it really challenging. Like, there's a tendency to want to make everything in language. But maybe that's not the best way to do it. So, and computers are different than humans. Maybe the way we transfer things into computers, like, we can program a computer. We can put the knowledge we want into a computer. You cannot do that with a child, right? And so, yeah, there's this sort of challenge of sort of translating the transfer of, designing effective interfaces for transferring knowledge between people and machines. So it's like we want to take into account the way humans do it, but we don't want to constrain ourselves to that because that might not be the best. I'm not sure I answered your question, but...
No, you definitely did. How... This is a quick aside. Do you sometimes worry that people rely on LLMs too much in education among students?
Sometimes would be an understatement. I actually think that it's a mistake. Like a vast multi-billion dollar mistake. That's my opinion of it. I think that we should be more cautious about the science of learning behind these technologies. And my guess is that there probably are benefits. Like the technology is amazing. There are good things there. And I do think it increases our potential to create educational experiences that are engaging, that we can scale because the knowledge is built into the LLM and we can leverage that knowledge. But I think that if it's not thoughtfully and done in a science-based way, I think we run the risk of actually making things worse than what we had before, especially if you take into account the cost. So right now, it's hard to know exactly what the true cost of the language model is, right? It's intentionally hidden. But if you look at there's several of these news articles that come out about the sort of tax, the balance sheets of companies. And OpenAI is basically eating billions of dollars of losses a year. And I can't remember the exact, don't quote me on the exact details, but they don't expect to be profitable until several years into the future where they have positive profit rather than losses. And so what that means is that they're eating losses to accrue market share, to make people dependent on LLMs. But what happens when the prices start coming up? Right now, I don't remember how much we spend on, if you look at just at K-12 federally, how much money is sort of allocated for technology per student, but it's not that much. Probably less than $20 a student a year. And is the LLM, when the true cost starts to come out, is it going to be more than that? People won't have access to it. Many people still don't have good, reliable internet access. I mean, in certain places in the country. So I don't know. I mean, there are challenges with it in terms of the rollout and the deployment. There's challenges with it in terms of like, is it just making like teaching people things that are incorrect sometimes? I would say about 85% of the time is probably correct, but 15% of the time it's just giving you bullshit. And I don't know exactly what the impacts of that will be. And then there's like the environmental, like, we're building data centers to power all of this. We're consuming water. We're, considering nuclear because we don't have enough power, cheap power to run these things. I mean, there's secondary effects on, of just the infrastructure. So I don't know if all of that is worth, I don't know if the cost benefit makes sense.
There's that point you made in Val that LLMs lack reasoning capabilities and point out that it's difficult for them to say, I don't know.
Yes.
And honestly, I feel when I'm interacting with an LLM, there's almost an illusion of knowledge that comes about, oh, just because it's really fluent and it's answering my question really well, that it probably knows what it's talking about. And there's a real danger there. We lose our sense of critical thinking. How are you as an educator trying to combat this over-reliance on LLMs?
As an educator, not just as a researcher, maybe both. I was just going to say that there's a really interesting metaphor that I heard for language models. It was a review of all of the tricks that psychics use to trick people. And there's like, the particular article I was reading was maybe like 10 tricks. And LLMs do all 10 of those. Like they give the illusion that they're effective, but a lot of the real input comes from the users. Either from their data or from what they put into the prompt as they're sort of like trying to steer it away from the mistakes. Another classic story you might look up on Wikipedia is there's a horse called Clever Hans, and it was a horse that could do math. Like it could do simple mathematical reasoning. And it turns out that there's a psychologist that went to study this horse that was apparently doing addition. And what they found was that the trainer had some cue that they were inadvertently giving that the horse was using. So in some sense, the trainer was doing the math and the horse was responding to it. And I think there's actually more of that going on in LLMs than I think people suspect. It's the reinforcement learning from human feedback. It's designed to get positive reward from you, not to give you facts that are right or to tell you things you don't want to hear, So yeah, it's like it's engineering. It's like figuring out how to hack you the way a psychic would to accepting and liking its response. It's a little bit terrifying. And but your question about how do I as an educator? Well, I think partly I'm not opposed to people using language models, but I do try to design assignments in a way that it's difficult to use language models on them. Like it would push the boundaries of what would be like on the web. For example, in my knowledge-based AI class, we designed a game, a teaming game, and they have to write design, knowledge to control an agent in that game. But that game doesn't, it isn't it isn't on the web. So in some sense, you'd think that if the language model could really reason, it would be able to do like a novel thing that it hasn't seen before. But often that is not how it works. It's quite, if you take it outside of what is in its training data, it usually doesn't do very well. So I often push my students in spaces that are difficult. Like I design the assignments so that they don't exist on the web. That's one thing. But I guess more generally is I have increasingly been trying to make my classes more discussion based, more about that social, like I would say I kind of joke with students. It's like the secret curriculum, like what you can't find on the web, and to try to provide that sort of experience, the like mentorship that would be hard to get from ChatGPT. It's like every time you interact with it, it's this first time. Uh, it doesn't know you or care about you in a way that, I mean, I hope I try to care about my students. So, and my experiences are unique, and I share personal experiences and, working with AI, navigating careers in this space that I don't put on the web. They probably aren't on the web. So the LLM's not going to be able to generate that.
Your I've noticed a lot of students have positively reacted to your human AI interaction class. They said that they would really look forward to the discussions that would happen in class. And I was wondering if, you could elaborate on what this class was all about and how it pushes students to think beyond their bubbles and consider different disciplines and patterns of thought.
Yeah. So thanks for the mention of positive feedback. That's so nice to hear. I guess the class, I think of it in terms of two levels of human AI interaction. On the one is like what I would think of as like big human AI interaction, like big H, would be societal. What we're talking about with language models that, require all these resources. In some sense, they are. There's a really interesting paper it's titled "Do Artifacts Have Politics?" And basically, it's saying that things like nuclear weapons can only be created within certain societal organizations. Like you need to be able to sort of organize the resources in a certain way to make that possible. And I think LLMs are like that. Like, if we didn't have corporations, we might not have LLMs today. So, and in some sense, I would say that the politics that makes corporations possible is what, like, in some sense, those LLMs are an embodiment of that sort of capitalistic, neoliberal social system that we have designed. Like, they wouldn't have been possible without what we have today in terms of our companies. And so in some sense, like, the value systems of those organizations are represented and imbued within those technologies, and they reinforce those value systems. So I guess what I'm saying, as an example, in my class, we talk about the broad impacts on society of AI. The idea of AI as a power enhancement tool. When you use AI to replace 5 workers, in some sense, it's giving the person who controls that AI more power than they had before. And what are the implications of that? Like, why would we want that? What are the risks of that? So my class looks at these kinds of things. And, we take a very historical perspective coming from some very early, there's a really classic paper from one of the DARPA directors, Lick Litter, on, human-computer or human-machine symbiosis and a vision for how humans and machines can work together symbiotically, to more critical views, sort of like original AI doomer kind of stuff, like, The Human Use of Human Beings by Norbert Wiener. I'm not quite sure I said his name right because I just read it all the time, but yeah, I mean, so we look at these sort of big picture stuff. Then we also zero in over the course of the semester to talking about what I would call small human-computer interaction. Like, how do we actually build an interface to be natural? What does it mean for that to be natural? How do we evaluate its naturalness? How do we, like, what are the elements of systems? We look at many examples of systems that I think fail or succeed at being natural, for example. And then we kind of blow back out again. So big picture, kind of into this sort of like, how do we actually build these kinds of systems? And then we sort of talk about what the future and the implications of these systems that we're building might be, and how we can have a voice in the design of those systems. I mean, many of the people in my class will go on to get PhDs, will go to work at Meta or Facebook or OpenAI. So how do you navigate having a voice within the creation of these kinds of artifacts? And I think it's not just a technical class. It's like, how do you advocate for positive technologies? And I think that's difficult to do when there's a lot of pressures to increase efficiency, to, you could potentially get laid off if you dissent, you're being replaced by, Microsoft laying people off so they can spend more money to underwrite LLMs. Like, you don't want to, how do you speak up or advocate for something that is better for people? So we talk about that kind of stuff too. Yeah, it's fun. I learn a lot. I don't know the answers to most of the things. It's more of we explore the problems together.
I'm so curious because, your background always tells me, yeah, this guy's a computer scientist. He's into mathematics. How did this interest in all of these disciplines come about? Psychology, history, understanding social structures. How did you push yourself to read so broadly and take in so much more information?
I don't know that I do read broadly and take in lots of information. I mean, I think that's a nice story I could tell myself that I do that. I think it's just been, everybody has a unique experience. Like, your path and my path are different, and that's what's so special about everybody's diverse perspectives and views, is that we all have different experiences. Like, for me, I have formal training in AI and learning science and HCI, and that I had great mentors and instructors that pointed me to the core ideas in those spaces. And I would say I probably don't read as much as I should, because, well, frankly, I think we're in a weird point in academia where people are able to write papers faster than they can read them. Wonder why that is. I think most of the papers that are coming out are actually very incremental and repetitive. I don't think you have to read it all. But I think if you have good mentors, probably not questioning an LLM about what's the best thing to read, but like somebody who actually has a sense of what the core ideas are and can point you to those, you don't have to read more. You just have to read the right things. So, I guess I would say that I've been fortunate to have had the opportunities and experiences that I've had. It didn't always feel that way. It often felt like things weren't working and I needed to make a change. But that inadvertently gave me experience in 2 PhD programs with the training from both and the mentors from both. So it's that like random walk that we were talking about at the beginning, like things in my control and things I had a little bias, a little bit of control, but a lot of it was just how the cookie crumbled.
Because it's crazy because, you honestly cannot predict how your life is going to go. What gave you the faith that this was your path, human-computer interaction? Did you have a vision for the kind of future that we all would want to live in?
Sure. So you can't control what's going to happen, but you can have a goal. And the goal can be changed at any time. So, what my vision for the future is today could be different than my vision for the future a week from now or a month from now. I've looked back at things I've written from like 10 years ago, and I have been surprisingly consistent. Like my goal around, building machines that can learn like with and from people and teach people has been that way for probably more than 10 years now, which is, was kind of, it is somewhat intentional, but like it could have changed. And I guess, yeah, my view is I want to try to understand minds still. I want to be able to understand how we exchange knowledge. And I set a goal and I just work towards it. But I try not to fall prey to what people would call the sunk cost fallacy. Like, yeah, sure, I've invested all this time and energy in that goal, but if a better goal or I saw something as a better opportunity, I mean, I would change. And the cool thing is, and my experience has kind of taught me that even when you pivot, all the experiences you had before are not wasted. If you still have those experiences, it makes you, makes you unique, and brings a perspective that others don't have. So, yeah, I mean, I guess I would, if I was giving advice, I would say, pick a goal for a future that you're excited about, that you want to have come about. Like, I wouldn't design for a dystopia, you know? Um, and I just take action to try to realize it. And, if things change, I could set a different goal and then I will work towards that. And, sometimes it's changing because of my choice, and sometimes it changes because things outside of my control. And that's okay. Yeah, that's the random walk part. You just have to it's just the reality of life, I think.
Yeah. Well, I think now is the best time to wrap this conversation up, Chris. I'm so grateful for your time, and I will say this: you are really impactful educator. Your impact is clearly seen. I've interacted with you firsthand and seen the kind of impact that you have on students, and I just want you to keep doing the awesome work that you're doing. I hope to see more of what's to come.
Appreciate that. Thank you.